Dear students, welcome to my YouTube channel. In this lesson, we will do some examples of Fourier series. Okay, we can write f of x equals to Euler's formula for a0 is here the first interval is from minus pi to 0 and the function is 0. So the integration becomes minus pi to 0 and the function is 0, so 0 into dx. Okay, and the second interval is from 0 to pi and the function is k. So the integration becomes 0 to pi, function is k, so k dx. Okay, Euler's formula for an is here the sine function is 0 for both upper limit and lower limit. So the Fourier coefficient an becomes 0. Okay, Euler's formula for bn is cos n pi is 1 when n is even and cos n pi is minus 1 when n is odd. So we can write cos n pi equals to minus 1 power n. Okay. So Bn is 0 when n is even because cos n pi is 1. So 1 minus 1 becomes 0. Okay. And Bn is 2k by n pi when n is odd. Okay. We found a0 equals to k, an equals to 0 and bn equals to 2k by pi n when n is odd. Okay. Now put these values in the Fourier series expression of the function, that is this is the required Fourier series representation of the function. Okay. Next question is for this question the first interval is minus pi to 0 and the function is 0. Okay. and the second interval is 0 to pi, and the function is pi x by 4. Okay. Euler formula for an is for this kind of integration we use the UV formula for integration, that is for this take xhu and cos nx v. Okay, so the integration becomes Euler formula for Bn is here use UV formula for integration and take xhu and sin nx v. Okay, now use these values in the Fourier series expression of the function. Okay, cosine series exists only when n is odd, because this term becomes 0 when n is even. Okay, so the cosine series becomes the sine series becomes this is the required Fourier series expression of the function. Okay, the sum of the series at x equals to pi is now substitute x by pi in equation 1. We will get here for x equals to pi, sine series becomes 0, so only cosine series exists. Now equate equation 2 and 3. We will get